Hi guys, this is Faizan and welcome to today's session on data structures using Java. So today we're going to implement some data structures and the language that we are going to use is Java. So before we start, can you guys quickly confirm in the chat section if I'm audible or not? Is there any noise that you are hearing or any echo so that we can rectify it here right now? Okay. Cool. Quickly just give me a yes or a no in the chat. And in the meanwhile, while we wait for others to join, let me give you a quick tour of how our academy looks like. So in our academy, we all know about it, the Great Learning Academy, right? We have 80 plus courses available right now. You can see if you just click on the in the URL, you will type greatlearning.in/academy, right? You okay? Voice is echo. Okay, just a minute, guys. I will rectify it. Cool. So yeah, so how it looks, you will be having some live sessions, the upcoming live sessions, including mine as well, right? Okay, so you have all the live sessions that are going coming up this week, right? So after that, you have some popular courses, data science. If you want, if you are interested in data science, you can click on data science. Similarly, if you are interested in IT and software, click on it, and you will get the list of what the courses that are available. And after the completion of your course, you will also have some quiz at the end, right? And okay, I can see voice is clear. Okay, great. So after once you are done with the course, you will have an assignment, and after qualifying, you need to qualify for getting a certification. You need 6 out of 10, right? There are 10 questions at the end, and if you get 6, you will get a certification, which you can easily add it up into your resumes and LinkedIn profiles, right? So you have digital marketing. Some of you guys were asking about ethical hacking, right? That too we have here, right? So designs courses in Hindi. Some of you are looking for courses in Hindi, so you guys can check these courses as well. Okay, so this is it, and you can just go through it once the session is over. Okay guys, so now let's get started with our session, data structures in Java. So the table of content, what are the things that we are going to cover in this session are what? First we are going to talk about what is Java, a little bit intro, then data structure, what is data structure. And since it's a 1 hour, audio is not clear. Yes, this is the first class. Yes, Mohini, is there any problem that you are facing regarding? Okay, your voice is echoing. Is it clear now? Okay, great Shivam. Okay, Mohini has deleted. Cool. Yes, Harpreet, these are all the courses are free, and you can just go through them, whatever suits you. You can just complete the course, and after the completion you will get a certification. Okay, cool guys. So since it's a 1 hour course, so we are going to we will be implementing these data structures, and once we are done with it, maybe we will have a session or two regarding the other data structures that we are going to implement, right? So in this session, what we are going to do is arrays, linked list, and then stacks and queues. So here we will have both the implementations, right, using arrays as well as linked list, right, for both these things. Okay, cool guys. So now let's get started. So we have right now we have 51 students that were watching. I want a like from each and every one of you. So quickly like this video, and let's get started. Okay, cool guys. So now what is Java? We know what Java is. It's a programming language which follows object oriented, which is an object oriented language, right? We have 4 pillars in it, right? What are those pillars? Inheritance, abstraction, polymorphism, and encapsulation, right? It's a high level language, and it was originally developed by Sun Microsystems. It follows the principle of Vora, what you see, write once and run anywhere, right? So what do you mean by this thing? If you have a Java supported platform, right, and in that you have compiled it, then you don't need to recompile it. It can be run as many times as you want. Okay, so this is all. If you are interested in a full course or a course that is entirely on what Java, here we have a course available on it, both in Hindi as well as English. Okay, cool. So now what is a data structure? It consists of 2 parts, data and structure, right? So it's a way to arrange data in computers, right? So whatever you store, right? So you have something that if some let's suppose you want to store something in your machine, right? What do? You store it in the memory, right? And how you store it is what do you mean by what we have these data structures. So different data structures, different stored differently in computers, right? So we are going to talk about these as well, right? You if you want to store data in linear fashion, you have arrays, linked list. If you want some restrictions to be applied on those things, right? You have stacks, which follows the principle of LIFO. You have queues, right? You have hierarchical fashion. We'll talk about it in the next session. Trees and graphs. Okay. Now, without wasting any time, let's get started. Okay. Okay, thank you so much. Okay, clear voice. Now let's start. Okay, so now we have arrays, right? So array is a linear data structure, right? What do you mean by linear? So basically your data will be stored in a linear fashion and it will be stored in a contiguous memory locations, right? Let's suppose this is your memory and you have this memory. Let's suppose this is a memory and for simplicity I'm going to use the addresses as what I've used. It's a hexadecimal number, but I will use integers, right? Just for the sake of simplicity. Let's suppose all of these are filled and you have chunks of memory available. Here is here are 4 bytes available, here 4 bytes and here 4 bytes. Now if you want to store 3 elements, right? I'm talking about integer. Integer takes 4 bytes, right? Integer takes 4 bytes. Now you have chunks of memory available here and here and here. Can you store 3 elements? No. You need to have contiguous memory allocations, right? Just like this. So if this is 101, 100, and then it should be 104 and it should be 108. So 4 bytes for each the elements, then you can store the elements in an array, right? So it stores contiguous memory locations. Elements are stored in a contiguous memory locations, right? You can access randomly. We have something that is called indexing. Now can anyone tell me why indexing starts from 0, right? In arrays, we all know about it that when you have an array like this and indexing starts from 0. So why does it start from 0? Because name of the array represents its base. Okay, I will slow down. Okay, so that was something that was good to know. That's why I rushed through it. No problem. Akshay, let's go slowly. Okay, so we all know that when you talk about an array, right, the name of the array represents its base address, right? You have a base address that is associated with this array. So let's suppose you have 100 here, 104 here, 108 here, right? Yes. Okay, Muyuk says so. Yeah, that can be a reason, but let's focus on this thing 1012, right? So now if you have ARR, that means you are dealing with what? 100. That means represents as base address. The base address of this array is 100. So now if you do something like this 0, that let's talk about arithmetic, right? So when you talk about this index, so it is something 100 plus 0. Now this 0 and when this is 101 plus 1. So if you think about pointer arithmetic, right? If you think about pointer arithmetic, so this 1 represents here 4 bytes. So you will be at a position of 104. So that would have been your second element. So that is the reason your indexing starts from 0. So that when you add up 0, it still give you 100, right? So that you are on the first element. So that is why we have ARR of 0, which is pointing to the first element. So this is the reason that indexing starts from 0, and with the help of these indexing, you can easily access elements randomly. So if you want to access this third element, you will go directly ARR of 3. That's it, right? So it stores homogeneous elements. That means if it is in an integer array, you can only store integers, right? 5, 4, 3, 2, 1, right? 5, 4, 3, 2, 1. That's it. Okay. So now these things are clear. Linear data structure can access randomly homogeneous elements. Now syntax is there are 2 variations. So first is that you write an array name, you have your ARR and then the square brackets, right? And if you have something, then you can write these subscripts first. We are talking about 1D array. Okay, yes, kindly repeat one more time why we start this. Nikhil says okay, let's repeat that thing. So let's suppose we all know when we talk about this ARR, right? This ARR represents its base address, the name of the array, right? If you have read, or if you might not have read, that is the different case. So in Yashwant Kanetkar, all the good books, you see name of the array represents its base address. Now if you have the name as ARR, it is pointing to base address, which is the base address of your array, right? Let's suppose you have this A0123 and you have something 5 4 3 2 1, the elements in the array. Now it will be having some address. For simplicity, I'm taking 100. Okay, Sukhdev, I will go slowly. So this is having 100, right? So I want to cover many things, that is why I'm speeding up. Okay, I will go slowly, no worries guys. Okay, so now this is 100. This is the first base address of this element. Now what will be the second? Since integer takes 4 bytes, so we have 104 here, right? Then we have 108. So for simplicity, these are hexadecimal numbers, right? So for simplicity, I'm taking integers. Okay, 112, right? And then you have 116. So if somehow if you have done this thing, now if indexing would have started from 1, that means ARR of 1 represents the had you started from indexing 0, right? So have you started from this thing from 1. So now what does this mean? This means 100 plus 1, right? This is same thing as this thing. Okay, now now it takes 4 bytes. This 1 represents 4, so you would have at the position that you would have get will be 104. So this is nothing but the second element. So now if ARR of plus 0 you are doing, that means 100, and you will be pointing to the first element. Okay, so you have two variations, and the first you will write the subscript, and then yes, since one element of an integer array takes 4 bytes, Mayuk. Not if it's a character array, then it will take only 1 byte. So let's suppose if you have a character array, and in that when you do 101 plus 1, it would have been pointing to 101, not 104. Okay, it depends upon the data type of your array and the elements that you are storing in that array. Okay, cool. So you have these two variations, and you can initialize and declare it in the same line, just like this. You have name of the array and then the subscripts. We are talking about 1D arrays, right? So then you will store 1 2 3 4 5, and that's it. Okay, done. Cool. So now this is it. Okay, now let's talk about some advantages. So advantages, simple enough, that you can access randomly with the help of ARR, that is the name of the array, and then you will be pointing to some index. Done. So you can access randomly. Easy sorting and iteration, you can easily sort and iterate. Replacement of multiple variables. What do you mean by this thing? Let's suppose I told you I want you guys to store an roll number of 5 students. So what you have done before arrays, you would have taken R1 and you had stored integer R1, and then you stored 10, let's suppose. Similarly R2 20, R3 30. Okay, so R3 is 30, and so on. R5. So now you might be thinking, okay sir, these are only 5, let's take 40. So these are only 5 roll numbers, so you can easily declare and initialize 5 variables. Now let's suppose I told you there are 600 students. Now what you have done, you would have created 600 variables. Now it's an easy replacement of multiple variables. How? Now you will be creating an integer array, naming it roll number array, and giving it a size of 600, right? Why array is an object in Java, and why don't you say it in an object in C++ when they are having same operations? So Nikhil says that why array is an object. So basically everything that you write, everything is in the form of objects, right? Now in C++, it is not known as object, because that is not a fully object oriented programming language, or C++, right? But your Java is fully object oriented, because there is something called as wrapper class, right? You might be knowing if you have some idea of Java. So there is something called as wrapper class. Now if you have int a, now in C++ this is a primitive data type, but in Java this integer is converted into a wrapper class, that is integer, which is nothing but integer. So it's converted into it. So this is how it converts primitive data types into objects. So that is the reason in C++ it is called an object, in Java it is called an object, and it's not called in C++. Okay, cool. So now these are all the advantages that we have. Now let's go ahead and let's talk about disadvantages, right? So the first disadvantage is that size is fixed. Now if you have something ARR of 5, that means you're only storing 5 elements, right? Now if you want to store 10 elements, you cannot, right? So it is difficult to insert and delete. Why? Let's suppose you have this array, right? Let's quickly define an array 1 2 3 4 5, and let's one position is empty. Okay, now I told you, please insert at this location. I want you to insert 10, and rest of the elements should remain in the same order. So what you have to do, you just have to insert here. If you have inserted here, then 2 would have gone, right? If you have inserted 10 here, then 2 would have gone. But I don't want that. Now what I need, what is an alternative of this, that I need frequent swapping. So what I will do, I will swap this 2 here, and using 3 variables, right? So we will swap all these values, and now whatever array will look like is something like this: 10, 2, 3, 4, 5 and 6, right? So there's a lot of swapping that is required when you're trying to insert, right? And similarly, when you're trying to delete, let's suppose you're deleting 10, then you again need this swapping to be done, right? So this is the reason that there is a difficulty in inserting and deleting an element, right? So let's suppose your capacity and your occupancy is less. Now your capacity is 100 and your occupancy, the size of the array is 100, and you're only storing 2 elements. Then that means 98 into 4, and whatever is the output of this, these many bytes will be wasted, right? Now this is a waste, right? So most of the array gets wasted, right? This is another disadvantage. Now it needs contiguous memory allocation. I told you earlier, you need, if there are chunks of memory available and you want to store let's suppose 3 elements, you cannot. This has to be a contiguous memory allocation. That's it. So this is one of the the several disadvantages that you have in arrays. Now applications, if you want to store something in a linear fashion, then you will use this, and it's suitable for elements which requires frequent searching. So we have some algorithms, that is binary search and linear search. We talk about those as well when we cover some algorithms, maybe in next few videos. Okay, so algorithms are there, so you can easily search an element in an array. Okay, cool. So these are all the applications. Now let's see the demonstration of it. So why we use wrapper class in Java? Just to make it an object oriented, completely object oriented. Okay, so that was a question I wanted. So okay, that is the question I always wanted to ask, that how a user can define the size of an array. So this is the disadvantage, right? So what is a binary tree? We will talk about binary tree as well in the next session. Okay, let's try. So I don't face memory issues. So because right now you are using kind of a supercomputers. It was earlier the case that you had limited memory, right? Right now your memory is not limited. So at most you can store almost millions and trillions of data in your system. So that is why you don't get this memory issues. So for that, in order not to get such issues, you use linked list, right? So that you cannot use something, if some memory is not available, then you're trying to insert something which is not available for you guys, right? Let's suppose you are trying to insert 20 and 20 bytes of memory, right? 20 into 4, that means 80 bytes of memory, and that chunk of memory is not available, right? So at that time you will get an issue. But right now we have systems which with huge amount of memories, right? It was the case when earlier, before 10-20 years ago, wherein our memory was limited, right? So this is the thing. So even if in Java there is something called as garbage collector, right? You have garbage collector Nikhil, so you will never face such memory issues, because every time the garbage collector sees some location or some variables which are not being accessed, they are removed, right? They are deleted on their own, right? So now let's see the demonstration, quick demonstration. So you declared an integer here, an array price of pen, and in that you declared the size, right? 5, let's suppose, and then you use scanner to insert the elements, and one by one you traversed and inserted all the elements, then you print it. So it's simple enough. Now let's go to our first important linear data structure, that is linked list. Okay, so now what is a linked list? It's a linear data structure, right? We know this thing is for sure, right? So because elements are stored in a linear fashion, so elements can be stored as per memory availability. Now whatever was the drawback in that, let's suppose you have these chunks of memory available, right? So now let's suppose you have these chunks of memory available and you want to store these elements, right? So in this case, array would have not been able to do this thing, right? So now, but in linked list, these elements will be linked together and it will be utilized you will utilize your memory much efficiently. Okay, So as per the memory availability, great. So now can access elements in a linear fashion. So you will have to you can access elements in a linear fashion. In there's also a drawback in linked list. Let's suppose these are our nodes and you want to access this element. You cannot directly access this element. You need to traverse one by one. We will see how this traversing is done. It stores homogeneous elements just like what we saw in arrays. It also stores the similar data types. Now if you're storing integer, you can only store integer data. Okay. It's dynamic in size, so one drawback is gone, that in array we have to specify the size. In this we don't specify the size. Easy insertion and deletion. Let's suppose you want to delete this thing. Now you will just link this thing to this and done. Just by replacing one link you have deleted this. Now you want to insert something and you will just link this thing to this and this thing to this. Done. Just by changing the links, it's easier to delete and insert in linked list. The now starting node is very important, as this will be the head node, and with the help of this head node, you will be able to traverse through whole linked list, right? So now whatever you do not change your head node. Okay, this is very important. Okay, we'll see the implementations as well, and at that time we'll see how to keep track of these things. Okay, now advantages: dynamic in size, that is simple enough, right? No wastage of memory, right? These are all the advantages. Easy insertion and deletion just by manipulating one link, right? And efficient in memory allocations, right? What was the previous code you skipped? Okay, I didn't skip any code. It was just the array implementation wherein we declared an array and initialized it and then printed it. That's it. It is simple enough, right guys? So tell me the best book of Java. It is the best book of Java and data structures. You have in Java there's something called the book is named the Black Book, right? It's a reference kind of a book. You can use that. And for data structures there is Corman, right? You have best book available, that is Corman. Okay, so in that you have data structures as well as algorithms, right? So it uses memory efficiently, right? Because since it is using these chunks of memory and linking them together, so you are using your memory very efficiently. You're not wasting any memory. Okay, good. So now what are the disadvantages? If head is lost, then your whole linked list is lost. That is one thing that whenever you deal with linked list, you always keep. So Mayuk says for I equal to 0, Mayuk, what are you trying to say? For I equal to size and I less than position. So this is not. Have I written this thing here, Mayuk? This is something that price of the pen dot length. That means length of the array. That is 5. You can when you talk about arrays, there are some methods associated with it, and this dot length represents its length, that is 5. So there is no such thing. Maybe you're going ahead and whatever you're trying to say, I can't figure it out. Okay, cool. Right, so now this is done and advantages is done. Now disadvantages, right? The head node is lost, then whole linked list is lost. You cannot access elements randomly. Okay, so applications, when your memory is limited. Now this is the thing that Nikhil was asking, why don't we face memory issues? Now if your memory is limited and you want to store as much elements as you can, so you will use this linked list, and you will be using your memory very efficiently, right? So it's suitable for applications where you require frequent insertion and deletion. In that case you will be using linked list and not the arrays, because insertion and deletion will take much more time. Okay, so now let's see the implementation of this thing, and this is very important, guys, right? If you don't understand anything, stop me at that moment and I will repeat it. Okay, so now let's suppose this is your class linked list node. First you define the structure. Now you have two data members, right? You have two data members. One is data and the other is next, which is nothing but storing the reference of your next node, right? These are all the nodes, right? Let's suppose this is data and next. Now this will be pointing to this, so this next will will store the reference of the node, now of the next node. Now that is the reason why this is written here, that it will store the data type is what, the linked list node, because it will be storing the reference of the next node. Okay, simple enough, right? These are two data members, right? And this is a constructor wherein you will be, whenever this constructor is called at the time when you create objects, right? This constructor will be called, so it will be using something like this, right? Let's suppose you have 5, you have called you have this is a parameterized constructor, and you have sent 5 as in the data to store, right? So 5 will be used here in the data part, and in the next part it will be null because we are using this thing. Okay, it's not pointing to any, there is no node that is that this node is pointing to. Okay, now this is the thing, and it will be having some kind of a reference or the address, which is nothing but 1000, right? So now this is the first thing how you create your nodes. Okay, done. Let's move ahead. Okay, so now this is the done. Now in this case what we are doing, this is the code for inserting an element or inserting the node at the end. Okay, so in the end, so whatever your linked list is, let's suppose this is your linked list, so you will be always inserting an element at the end. So Khalid says, how do you store addresses on the next node here in Java? I remember in C I used to use pointers. How do you do it? So there is no such thing, Khalid, in Java like pointers, but it is not right. It is something internally it uses pointers, but it uses it automatically, right? So these references are nothing but pointers, but you don't say pointers in Java. So these are references, right? Just like your pointer act, it will do in the same way, but you don't have any pointers in Java, so you don't specify this term anywhere. Okay, you don't have any pointers, but in internally it does the same thing like in C. Okay, cool. So now you will be inserting this new node at the end always. Okay, this is the code for that insertion at the end. We'll see how to do it in the beginning, how to do it anywhere, right, in this session itself. Okay, cool. So now what you have, let's suppose you have this data and you want to store 10, right, and this head node. Now there will be two cases. What are those two cases? Now listen carefully. Now these are the two cases. The first case will be that your head is null. Now whatever is this head, this will be the first node. Now you don't have any nodes. Now this head will be null. Now in other case, this head can be the have some address, right? So have some reference, right? Now let's suppose this is your linked list and this is the address of this node, right? And this is nothing but your head node. Now you have this linked list available. It can be, there can be 1 element, 2 element, 3 elements, right? So call it different languages or different diagnostic. Yes. Okay, so now this is your head node, and let's suppose this is the address of this thing. Okay, reference of this thing, right? Now there will be two cases when your head is null and when your head, that means there are some nodes in your linked list, right? Simple. Is this point clear? These two cases, right? So now let's move ahead and clear this thing. Okay, now we will cover one by one. One by one we'll cover these things. Okay, so these two cases. So you have 10 and you have in head, it will be either null when you don't have anything, or it can be 200 when you have some elements, maybe 1-2 elements. Okay, so now what does this thing do? This linked list node temp, you are creating a temporary node and you are allocating memory, and when you call this thing, this means that you're calling the constructor. Now what does a constructor do? It will create a node like this in which your data is the key, that is 10 will be stored in the data part, and this is null, right? So you have some addresses here. Let's suppose this is 1000, this is the reference of this, right? This is the address. Now is this thing clear why it does this thing? Because we are using this constructor which is using this thing, right? The data part is whatever is the data, and then the null, the next, it is not pointing to anywhere. Sir, case 2 is not clear to me. So the case 2 is this thing that, let's suppose you have a list of nodes, right? There are nodes available in your linked list, right? So in that case, this is the first node and it is called head. So head will contain some address. Let's suppose this is 2000, and in that you have 5, 6, 7, 8, 9 and 10, right? So this is your linked list, and this will be pointing to, let's suppose these are addresses, 4000, 5000, 5k, 6k, 7k. Now this will be pointing to null because there is no node after that. So now this node will be pointing to this 3000. Okay, this node will be pointing to this 4000, this node will be pointing to this 5000, this node will be pointing to 6000, and this node will be pointing to 7000. Okay, so this thing is clear. This is the second case in which your head, in which in this. Okay, okay, just a minute. Let's try to focus on this thing, and we will see. Okay, try to capture this image in your head. try to think over it and we'll start again. Okay, so now these are the two cases. Okay, so now we are done with these two cases. So case 1 was when your head is null, and the case 2 was when your head contains what? Nothing. It is the pointer that is pointing to the first node, so head node will have a reference that is 2000. Okay, or 200, whatever. Okay, so now is this thing clear, Muyuk? So let me rub this thing and let's start again. Okay, so now what happens in here, these two steps are clear. Now this is the node that is created, this is the new node that is created, right? This is the new node. Okay, sure Amun, sure, we will work on that as well. Okay, cool. So now this is the new node that is created and this is our nothing but ttmp. Okay, now what does this step do? We are storing whatever is in the head. It can be null or it can be some reference. Now these two cases are clear to you. Now we are not changing this head, we never change our head. Okay, so that is why we are using this ttmp, and we are using this ttmp1, and this is also pointing to this node. Let's suppose you have head and it can be either it is null, that is your first node 50, and let's suppose you have only one node, so whatever is the address, that let's suppose 2000, it is pointing to this head node, so that we do not change our head node. Okay, so now let me just make it easier for you guys. Now let's suppose we only have one case, right? We only have one case that we are not having any element. Okay, simple enough, right? So now what does this thing will have? This thing ttmp will also be null, right guys? Done. Now is our ttmp1 null? Yes it is, right? This is null, we don't have any elements. So at that time we are doing what? We are making this head point to this new node. So we have this thing now. Will this thing will be executed? No, this is the else part, this is your if part, this is your else, and you will return the head. Now after the whole thing is done, you have a head here which is pointing to this node which contains 10 and null, and you have some addresses, let's suppose 1000, and you will return this head. Now this thing is this is the first case. Now let's suppose, now we will execute the same thing again. Okay, now in this case what happens? Now you have already this node. Okay, this is your one node. Now you're calling this function again and you're trying to insert again. Okay, now let's see what happens this time. Okay, now let's see what happens this time. So you are trying to insert 20 and in your head you have 1000 because there is one node, we just created it, right guys? Give me a quick confirmation. Now we are creating again a new node, naming it ttmp, and we are creating a new node and it contains 20 and this is null, and this will be having some address, let's suppose it is having address 2000. Okay, this is done, this is created with this thing. Now what we are doing, we are creating a temporary variable ttmp which is also pointing to the head node. So we have a ttmp1 which is pointing to the head node, right? So this is the second step. Now is our ttmp1 null? No, it is pointing to 1000, it is not null, so this step won't be executed. Now we go into the else part. Now we will traverse in this node, whatever we have here will traverse. Okay, so what we are doing, is ttmp's next, that is ttmp1's next null? Yes it is. So we will not execute in this case because this is the first element we are trying to insert at the end. Okay, so this thing will not be executed. Then what we will do, ttmp1's next equal to ttmp. Now we are storing something here, and whatever we are storing is 2000, so we are storing 2000 here, right? And now what happens, this is pointing to this thing. Okay, so now in nutshell what we have two nodes which are nothing, that this is 10 and this is 2000 here in the address part or in the reference part, and we have 20 and we have null here, and this is 1000 and this is 2000. This is your head node. Okay, Now let's do it once more, okay, so that things are clearer, much clearer. Now you have this node available to you. Now let's suppose you have called this thing again, okay, you have called this thing again, you're calling this function again, and you want to insert at the end. Now let's see what happens. Okay, so in the key, let's suppose you are trying to store 30 and your head contains what, nothing but 1000, right? So you have this 1000, the head, right? And now you're creating a new node will be created and it contains 30 and null. Why null? Because of the constructor. So you have this ttmp here, okay, and this contains, let's suppose, 3000, that is address. Now what does this step do? This will create nothing but a head, right? Now this ttmp is also pointing to this head, ttmp1 is also pointing to this head, okay, so that we don't change this, because once we change this, the whole linked list will be lost. Okay, now is ttmp null? No, it is not, it won't be executed. Now what happens? ttmp's next, is it null? No, it is not, it contains 2000. So what we will do, we'll increment our ttmp is equal to ttmp's next. So now this ttmp will be pointing to this thing. Okay, done. Now what happens again? Is ttmp's next null? Yes, it is. So we have exhausted this while loop, we will be out of this while loop, and what we are doing, ttmp's next, that is, we are talking about this location, please store whatever is in the reference of this ttmp. ttmp contains 3000, so this will be 3000, and that means we are pointing this thing to this. And after that, once it is done, then we will be returning head. Now you might be thinking, sir, why we are returning every time the head? Let's suppose you don't know the cases, right? Let's suppose you have such case in which what you're trying to manipulate the head, and once you are manipulating the head, at that time you need to return the head, so that it is clear, right? So this is your linked list, and this is adding an element, adding a node at the end. Cool, done. Is this thing clear? Quickly, there are 53 participants. I want a yes from each and every one of you. Is this thing clear? Quickly, guys. Yes, no. Quickly. I wanted to cover different things, but I don't think you will be able to cover that many things. Quickly, guys. Just give me a quick confirmation. Okay, Mayuk says yes. Quickly, guys. Okay, so now let's move ahead. Now what we are going to do, we are going to insert an element at a particular position. Okay, at any particular position. It can be first position, it can be last, and it can be your first position, it can be your last position, and it can be anywhere in between, anywhere. Okay, so now that thing is done. When we are talking about any position at the end, that means this is what, this you can do it individually, that you are talking about this specific case every time you are adding at the end, or you can do it in this manner. Okay, so now let's talk about this thing. Okay, now you have a key, the element that you're trying to insert. Let's suppose you're trying to insert yes, we will try to do, Naneshwar. Okay, so now we have this 10, and the position of this is, let's suppose, third position. Okay, or let's suppose in the first case where we will be manipulating the first position. Okay, let me just rub it again, the position where you're trying to insert. Okay, so this will be your first position you're trying to, and the head. Again, head will have two cases, either it will have some element or it will be having what, null. So let's suppose you will be having 200 or it will be having null. So now let's consider, for simplicity, let's not consider this case since you haven't inserted any elements. Let's suppose you have no element inserted in it and you have your head as null. Okay, so now in that case, now you will be creating a new node with the help of this step, right? ttmp equal to new node. Now whatever you have inserted here, the key will be transferred to the constructor, and you have something like this. This is your new node. Okay, this is your new node and it is called ttmp. Okay, this is pointing to this, and you have some addresses. Let's suppose you have what, 55,000. Okay, so now is your position equal to 1? Yes, it is. We are trying to insert the element at first position. Yes, it is. So at that time, what you're doing, ttmp's next, that means ttmp's next, whatever you store in this position, you're talking about this position, please store head in it. Since our head is null, that means we are storing null, right? Now our node will be something like this because our head is null. That's the only case. Okay, and then after that, whatever was the new whatever was this address, the address associated with this new node will be your head. So obviously it will be our head. Okay, is this thing clear? This will be our head. Now I will repeat the same thing, but this time I will be having this element. Okay, so now let me do, well, this thing is done, this won't be executed, and you are returning the head. Now let's do it again. Okay, you have to do it multiple times, only then you will get a hold of this thing. Okay, what is happening and how it is happening. Okay, now okay, so now you have this head in here, and let's do it again. Okay, now your key is 20, you're trying to insert 20, and your position is again 1, and you have head node. This time it is not null, this time it contains 5000, the reference. Okay, this is your head. Okay, done. Now you create a new node with the help of this thing, and you will be storing 20 in it, and this is null, and this will be having, let's suppose, okay, just a minute, you will be having 6000 here. Okay, so now this is your ttmp. Okay, done, this step is done. Now if position is equal to 1, yes it is, position is 1, our position is 1, and at that time what you're doing, ttmp is next, please store head in it. Okay, ttmp is next, ttmp is next, we're talking about this thing. Let me just use another color so that it is visible. We are talking about this thing. Okay, we are talking about please store head in it. What is head? Head is nothing but 5000. Now what we are doing, we are storing 5000. Now this is we are doing such this thing, right? We are linking this node with this. Now this is head. Now is this the actual head? No, that is why we are changing the head over here in this step. Now this will be our new head, so that is what we are doing. Please store. Now head will be pointing to this node, that is what we are doing. Head equal to ttmp, that is 6000. So now this is our new head, and this won't be executed, and we return the head. Okay, done, cool. Now what if your position is something else, right? Now let's cover that case, and then we are done with this thing. Okay, now let me just drop this thing, and now let me create a little bit of in this case what we will be doing, we will have some list in which we have 3-4 nodes. Okay, now let's cover that thing quickly, and we will go ahead with the different things. Okay, so now let's suppose you have these nodes 1 2 3 and 4. Okay, done, and this will be null, right? And this will be 1, we are storing 1, we are storing 2, we are storing 3. Okay, okay, so we are storing 3, and then we have 4. Okay, now in the address part you will be having 100. Let's suppose 100 is the address, 200 is the address, 300 and 400. Okay, so this will have 400, it is pointing to this node, it will be pointing to 300, it will be pointing to 100, and this is your head node. Okay, done. Now let's cover different case. In this case what you will be having, you will be having nothing but your key is whatever you want to store. Let's suppose you are trying to store 5. Okay, and your position is 3 at third location. Now this is first node, this is second node, and you want to store at this position. Okay, and this is your fourth node. Okay, and your head will contain whatever is in the head. Head is 100, right? Done. Now we will create a new node with the help of this, and you will be having this 5 over here, and this will contain null, and let's suppose this is having 500 as its address, and this is called nothing but ttmp. Okay, done with this step, done with this step. Now is our position 1? No, it is not. What? Echo. Okay, Khushbu, so just give it some time, it will be clear. Okay, so now your will this thing will be executed? No, right? This thing will not be executed. This if, just a minute guys. Okay, quickly guys, is this thing clear? Is the voice clear now? Quickly. Quickly guys. Just give me a quick confirmation. Girish, Adnan, Khushbu. Yes, sir. Quick. Okay. Thanks, Mohit. Thanks. Great. So now, will this if be executed? No. Right? Because our head is pointing to 100 and our position is not what? 1. Our position is 3. Now we go into the else part. Now again, same thing. We will never change this head. So that is why we are using this pointer TTMP1 that is pointing to this node, head node. Okay, this step is done. Now we will be traversing to that particular location, that is 3, and we will be inserting our new node there. Okay, so we have this iterator I, which is at starting it is 1, and we have TTMP. Is our TTMP null? No, it is 100. It is pointing to this node, so it is not 100. So this is true. This is true, right? This statement is true, and that means we are checking the next condition. This has to be true. Only then we can execute this for loop, right? So I is less than position. Is our I position less than position? So if we are trying to insert, that means we need to do position minus 1. Okay. So now in this case, what I is 1 less than position minus 1. So there is a misprint. Please use minus 1, position minus 1. So position is 3 and 3 minus 1 is 2. Okay. So 1 is less than 2. Yes, it is. So this is also true. And what you will do, you will increment this pointer temp. Please store temps next inside of temp. So now what happens? This will be pointing to this thing. Okay. Done. Next time it happens the same thing. Now I will be I will be incremented to 2. Is TTMP1 null? No, it is pointing to 200. So this will be true. And let me just rub this thing for the next case. Okay. Okay. Again. So is TTMP pointing to null? No, it is not. So this is true. And is I less than position minus 1? I is 2. Is it less than what? Is 2 less than position minus 2? That is 2 less than 2? No, it will be false. So this condition will be false and we are out of this for loop. Okay. Now that means our TTMP is pointing to this node. Okay. Is this thing clear? Okay. Now what is happening? Please store TTMP's next equal to TTMP1's next. Okay. So whatever is stored in TTMP's next. So we are talking about this thing. Okay. We are talking about, let me just use another color. So we are talking about this thing, this step. TTMP's next. Please store TTMP1's next. We are talking about this node and this thing. Please store this 300 inside of this new node. So that means what does this mean? This means that this TTMP is now pointing to this thing. Okay. This TTMP is pointing to this thing. Now you have two nodes that are pointing to this node. Okay. This, because we are inserting at this location, right? So we have two nodes that are pointing to this node. Now what is the next step? The next step is TTMP's next. Please store TTMP. Now we will be removing this link. Okay. Now we will be removing this thing, and inside of this location, whatever we will be storing is TTMP's TTMP. TTMP is 500. So we will be storing 500 in this. Now this link will be removed and this will be pointing to this node. Okay. So if I will just clear this mess, 1 minute, I will clear this thing and then I will show you how exactly it looks like in the end. Okay. So let's do it again. So now whatever happened, this 300 was pointing to this node. Okay. So now let's do it once more. So you have 1, you have 2, now you will be having here 5, then you will be having 3, then you will be having 4, which is null at the end. Okay. So now this is pointing 100, this is 200, this is 500, this is 300, this is 400. Okay. So now this will be pointing to what? 300. So you have this pointed as 300, right? This will be pointing to as it is. This is as it is, right? 400. Now this 2 is pointing to 500. Yes, it is pointing to 500, right? And then you have this thing. This is 100. This is 1, 2, 3, 4, 5. Now you see you have inserted a new node at position 3. Clear? Great. So now let's move. This will cover all the cases at the end, at the beginning, at any position. Okay. Now let's do it the same for deletion. So now the similar thing will be happening for deletion as well. You will not be creating any new node because you're deleting. Now let's suppose you have this thing, and these are your nodes, right? This will be your head, right? If your position is 1, that means you are deleting this first node. In that case, your head will change. Now your head will go here. So whatever we are doing, we are just doing head equal to heads next. So whatever was the heads next, please make head that. Now this will be your head, and this link is already this. You are not removing this link because now you cannot traverse to this. You can never traverse this node. You're just having your pointer over here. So this is your newly node. So this is the reason why you don't change your head, because if your head is pointing to this, you will never be able to access this node. Okay, got your point? So if you want to remove this link as well, so whatever you can do after this step, whatever you do, you will store this head inside a temporary variable, temp head, and after that whatever you do, temps.next equal to null. So you will be storing null here, and then this link will be broken, and then garbage collector will take care of this if your position is 1. Now if your position is not 1, at that time you will do the same stuff that you did for this thing. Okay, for deletion for insertion at any position. Okay, go through it and do the dry run as well. Okay, clear. So what is the importance of data structures? So anything that you store in your systems, right, in your memory, so you need to know how your data is stored, right? So if you know how is it stored, then only you can deal with the with complexities, right? So how let's suppose you are having you're trying to insert any element at the beginning in a linked list. Let's talk about linked list. Now you're trying to store you will be always storing at the beginning, right? You will be always inserting a new node at the beginning. Now what is the time complexity of this thing? If you know how it exactly happens, how it is storing the data inside your machine, how you are storing your data inside a machine, right? So only then you can decide, okay, this thing is happening in constant amount of time. So all the complexities depend on how you are storing your data. So this is one of the naive explanation. What is the importance of data? How you are storing your data? You should know it. Only then you can decide what is the complexity, right? Only then you can decide. Then you can be able to solve coding problems, right? Yes, Mayuk, you are right. So now what is happening? So this is your deletion. So now if you want to calculate the length, you can also calculate the length. Let's suppose you have these nodes over here. Now you want to calculate the length of the linked list. You have head pointing to this, right? In this case, also you have temp pointing to this. TTMP is also pointing to this. This is the first step. Now you have a counter that is 0. And is our TTMP null? No, it is pointing to this node. It is not null. Okay, so this won't be executed. We will go into the else part. Now is TTMP null? No, it is not. What you will do, you will make it point to this node. Now TTMP will be pointing to this node, and you increment your counter. Now again, inside this loop is happening these two steps, right? So again, is TTMP null? No, it is not. You will be having it's pointing to this node. What you will make it point to this node and increment your pointer. See, now again, is TTMP null? No, it is pointing to this node. Again, increment point it to this node and increment your counter. In point it to this node, increment your counter, right? Now is TTMP null? No, it is not. Point it to this node. That means you're pointing it to null. Increment your counter. It makes it to 5. Now your TTMP is null, and at that time you won't be incrementing the C, and you will return the C. C is nothing but this value. So how many nodes are there? 1, 2, 3, 4, 5. So you're returning the node. You will be returning the length. That is 5. Okay. Cool. So this was how you calculate the length. Now how you display the nodes. That means how you display these items, these data members that are inside your node. Okay, 1, 2, 3, 4 are the elements, and this is your head. So again, you will use a temporary pointer that is pointing, not a pointer, temporary reference that is pointing to what? The head node. And is your temp null? No. You will print whatever is the temp's data. Whatever is the temp's data, it is 1. You print it. Then make it point to this node. Now, had you use head only, if you haven't used this node, this temporary reference, if you have changed the head, then whole linked list would have been lost at the end. So that is why we are using continuously these temporary pointers. Okay guys, So now this is pointing to this and you will print this. You are pointing this to this and you will point to this. You are pointing to this, you will print this. You are pointing to this, you will print this. And at the end, you're really pointing to null and it won't print anything because you will be out of the for loop, out of the while loop, and you will be printing all the data 1, 2, 3, 4, 5. So this is to display. Now let's quickly try to cover stacks, at least one implementation that is using arrays, and rest maybe we can cover it in the next section. Okay, next session. So what is a stack? Stack is again a linear data structure and it follows the principle of LIFO. Okay, that is last in first out. That means let's suppose you have a stack of plates, and right now I'm restricting your insertion and deletion. How? I'm telling you that you cannot insert unless and until, you cannot remove unless and until you remove the top elements. Only then you can remove this element. All the elements should be removed. And insertion is also restricted. How? You can only insert from the top. Okay, you cannot insert something here. Okay, that is not done. So now this thing is called, what is this thing called? It is called last in first out. Now why is this called so? Because whatever you are inserting last, this is the last element I inserted, this is the first element that will be removed, because I am restricting my insertion and deletion in such a manner. And you will use a pointer that is top to do these things. Okay, now let me show you how. So this thing is clear. Only the top element will be accessed, insertion and deletion will be taken care of. So examples are stack of plates, stack of chairs. So now there are 4 major operations: push, pop, is empty, and peek. So these are all the 4 major operations, and these are all executed in constant amount of time. So Malik, so he was saying why do we need this thing? So now these are all the operations that are performed in constant amount of time. So only when you know that your insertion and how your elements are stored inside your memory, only then you will decide what is the amount of time you require to perform these operations. So all these operations are performed in a constant amount of time. How? Because there will be always a pointer that is associated to this top of your stack. So now if you want to insert, you will just increment this top to this position and insert. So this is not, you're not iterating through all the elements, right? You are just incrementing your top. Now this is a single unit operation, so that is why it takes a constant amount of time. Similarly for pop, you have a top iterator, that is this iterator named top. You have this top iterator pointing to the first element, and whenever you pop, you will just decrement your pop. This is also happening in a constant amount of time, right? Similarly, is empty. If your top is not equal to -1, that means it is empty. Else, if it will be having some value, that is 0, 1, 2, 3, 4, right? So it will be having some value. So you only check the value of top, which is again a constant amount of time. This operation is also a constant amount of time. So is it similar to HTML tags, because they also follow LIFO principle? No, they don't. Whatever they follow a structure. Not you cannot relate these two things together, Mayuk. These are something 2 different worlds, right? So you can say LIFO, you cannot say LIFO, right? The last in first out, because that means that whatever you have written at the end is the statement that will be executed first. That is not the case, right? It follows something that is first come first serve basis, right? HTML, FCS, FS. Right now, peek is similar to pop, but it will not remove. Okay, it will not remove. It is similar to pop. Peek is similar to pop, but it will not remove. It will do the same stuff, but it will not remove. So I was talking about top. That means you are decrementing the top. In this peek, it will not be decremented. Okay, you will just check whatever is the top. So it is also happening in constant amount of time. Okay, so these are all the things related to stack, right? And it follows, what are the advantages? It follows LIFO manner. Last element is readily available for use, and all the operations are these operations which I talked about were push, pop, and all those things will take constant amount of time. What are the disadvantages? Manipulation is restricted, as we can only access top. That is the disadvantage. And it's not much flexible, as we only have access to top. There's not much flexibility, right? This is simple enough, right? Now applications, if you have used recursion, stacks are used in it, right? You have something called as activation records, right? Now if you have let's forget about activation records. Let's suppose you have a function which calls itself again, right? And you do the stuff, it calls it again, right? And once it is done its execution, for example, you have written here return 1. At that time, at that time what happens, you have one returned, and after that it is pushed on the stack. This happens in such a manner that these are all pushed in the stacks. Once it is returned, it will be popped, it will be popped, it will be popped. Okay, so this is one application, recursion parsing. Browsers, right? Browsers, let's suppose you have Great Learning website. You went on to Google, and from Google you went to on GL, right, on Great Learning, and in that after you went into courses, and in that you went into full stack development, let's suppose. Now if you press a back button, it will go to this courses, right? It will not go to Google, right? If you press a back button, it will go to GL, it will go to, then after you will press a back button, it will go to Google. So it happens something like this. You have Google, then in the stack you have GL, in the stack then you have courses, then you have FSD, and once you are popping out these things, once you are pressing back, it will be popped. Okay, so browsers, editors, redo and undo options, these two options are again following the principle of what? Stack. Okay, now let's quickly try to do we have time? We don't have time, guys, so I will not demonstrate this implementation stack using arrays. Okay, now the slide decks have been shared with you guys, try to go through them, and if something is not understood, do let us know in the comments. Okay, and if you want a second session regarding this, also do write in the comments, and please like this video and share it as much as you can with your friends, so that we also feel that we are doing this, you are implementing this thing, and you want another session on this. Okay, guys, so do leave your comments and do subscribe to our channel. Okay, so is there any question that you want me to that you want an answer regarding which? So is there any NET exam course for NET exam? Not sure of, I have to look, Malik. Okay, so are there any questions? Quickly, guys, just you can write it, and also the slides will be shared. The code is also shared with you guys in those slides, so you don't have to worry about code. Okay, thank you very much, really helpful. Do you have a second session? Okay, on data structures, maybe yes, Moyuk. Okay, want a second session? Okay, great, we will work on that. Okay, cool. Any more question, guys? Do you want me to answer any questions of yours? Mandeep says thank you, guys. Okay, guys, so if you don't have any questions, so I'm concluding this session now. See you in the next session, maybe a continuation part of this. Okay, how is it helpful to the guys? These data structures, I told you, Rabindra, many times that thanks a lot, guys, those who are freshers. So for freshers, you will be dealing with this thing. If you are a fresher and if you are in a first year, now you might not be having data structures in your first semester, but it will be definitely in your second semester, and all the placements that you will be facing, the coding interview rounds, all these things will be helpful and they will be beneficial for you. So we want a next session as early as possible. Okay, Danishwar, we will work on that as well. Okay, don't worry, just write in the comments that you want a second session like this. Okay, and do like this video and do subscribe. Okay, so Rabindra, is this thing clear? For all the freshers, you will be having coding interviews, you will be having placements, you will be dealing with these things moreover. Okay, not in the first semester, but in the second, third and fourth, you will be having it there, and in fifth and sixth, you will be having so much pressure that you cannot go in this much detail when we will be having these interviews. Okay, at that time you will be just knowing, okay, what is the stack and how you will be using collection frameworks. Okay, so at that time you won't be able to go in depth just like what I'm teaching you in this session. Okay, guys, so thank you so much, guys. Okay, thanks a lot, guys. So yeah, we will work on that. We will have a second session on data structures. Okay, thanks a lot, guys. Thank you so much.